My name is Yves. I come from France. I'm 23 years old and I'm a student in Telecom Bretagne. So here in Telecom Bretagne we study in really great condition. In fact, the school is located near the sea and bordered by trees. So here we realize the importance of the resources on this planet, and thanks to the policies of the school, here all students are aware of the sustainable development and are involved in it. So in the future we know that engineers and information communication technology engineering will play an important role in the sustainable development. So every year Telecom Bretagne shows in different projects like ours and technology in harmony with the nature, with the environment. So we think it is the green design, and for example, this year, during we are working on the smart heating system, other students are working on the automation of the irrigation in agriculture, and to take care of different plants. So it's just an example, but there is lots of this kind of topics here in Telecom Bretagne. So to be consistent with our beliefs, and because we want to be actors of tomorrow, we decided to participate in the FTF Design Challenge, and we decided to build a prototype to show our idea. So in my presentation I will introduce you the smart heating system. On the one hand, why are we interested in the heating system, and on the second hand, the advantage of another system, and finally the improvement we could do in the future. So in fact, our idea is to reduce people's energy consumption for heating, but without affecting their comfort. So during the winter in France, the heating system represents about 70% of the consumption total consumption of energy. So it's the biggest source of consumption in a year, and moreover, around 20 degrees, when you increase the temperature by 1 degree, you have to increase your consumption by 7%. So for a small house is about 100 liters of fuel, and in euros is about 90 euros in a year. So in this context, each little economy will be interesting, and our system does it. In fact, until now, most of systems which control the temperature in a house use only one parameter, the internal temperature. We have thought of a system which conserve energy by giving several environmental parameters as input to an algorithm, which in turn stimulates the heating block in order to generate the minimum temperature required. So to do that, we integrate in our system several parameters, like the internal temperature, the external temperature, the percentage of humidity in a house, and the sunshine. Nowadays, those parameters aren't taken in account by regulation systems. The functionality is to make more efficient the regulation in a house thanks to those parameters. So, for example, if we are able to detect your system is heating, and whereas the sun is shining, it's not necessary to heat, and the economy will be interesting. To illustrate our idea, we make a little house, and we placed in this house different sensors, like you can see here, a sensor for internal temperature and humidity, here a sensor for external temperature, here a sensor for the sun, and we can note that the bulb represents the sun in our system. So all data from the sensors are sent to the microcontroller here. So the microcontroller is a low consuming device from FresscaleFTFChallenge. Is the HSC8, and in the microcontroller an algorithm calculates some new parameters, like for example the humidity, the humidex. The humidex gives the temperatures that we really feel, depending on the humidity. Then the algorithm gives a temperature instruction to the fan here, and in fact the fan regulates the temperature in the house. So the temperature may lower if the humidity enabled, and for example, or if the sun is shining. As like you can see here, I switch on the light, and our system is able to detect the sun is shining, and the velocity of the fan is more important, like you can see here. So to conclude, we can note this project. In this project, it was easy to have and to think of this kind of system, but the difficulties were in choosing parameters and make a link between them, because of the bibliography in this type of study is very poor. So it's the difficulty. But for the future, we thought of different improvements. Like for example, we want to add to the system another parameter, like the wind. The wind is very important here in Brittany, so we want to add to our prototype, and of course a screen to end the project. So in the future we can imagine a design which incorporates Zigbee technology to to facilitate the inclusion in house. And finally, the end product could be a product where the user can choose their parameters depending on his house and his region. So thank you for your attention, and bye bye.